We are now at lesson 10A. The term exponential growth is often used to convey the idea of rapid growth. However, not every instance of rapid growth is going to be exponential growth. So we're looking again at the puzzle posed by Leonardo of Pisa in 1202, and they're asking us to refer to the table of values from the preview. And the question number 1 is, how many rabbits would there be in the 13th month if none of the rabbits died? This is the time when you go grab the Excel spreadsheet in my math lab, start working through that, get an answer for the 13th month, and then come back and we'll work it together. So here's the spreadsheet from my math lab, and I want to work through a couple of lines with you. The progress here is once the rabbits are at young adult, they will breed another pair of rabbits. We have no juvenile rabbits to become young adult, but we have one pair of young adult to become old adult. So with this in mind, we have 1 plus 0 plus 1. We now have 2 total pairs of rabbits, and with it being pairs, we have a total of 4 rabbits. Let's keep going on the process. We're trying to get to the 13th month. Now that we have an old adult pair of rabbits, they'll reproduce to breed a juvenile pair. The old juvenile pair becomes young adult, and the old pair of rabbits are still the old pair of rabbits. And remember, we're assuming no rabbits are dying. So 1 plus 1 plus 1, we have 3 pairs or 6 total rabbits. We'll keep the process going until the 13th month. So juvenile rabbits, we now have a young adult pair and an old adult pair. So we've got breeding, and we'll have 2 new juvenile pair. The juvenile pair become the young adult. The young adult are going to come over here with the old adult, but there was already 1 pair there. So now we have a total of 2 pair, or a total of 5 pairs of rabbits. And that would be 10 rabbits. Let's do it one more time. We have 1 young adult pair, 2 old adult pairs, so that's a total of 3. So we have 3 new juvenile pairs being bred. The old juvenile are now going to be young adult. There'll be 2 of them. And the old young adult will now join the old adult, and so we have 3 total pair of old adult pairs. When we add the 3, the 2, and the 3, we have 8 pairs now, and 8 times 2 is 16. Well, I've already worked this one out, and working it down to February, 13th month, where are we? December, January, February. So February is our 13th month, and the question's asking, in the 13th month, how many rabbits would there be in the 13th month? And so I don't like what I have. Their answer is 203 for the 13th month. Let me go double check my numbers. So I checked my numbers. I still like my numbers. And, oh, I see. The 13th month is going to be January. Got it. So January through December, that's 12 months. Then the next month is the 13th month. Got it. And so we're going to have 233 pairs, or a total of 466 rabbits. So the objectives for this lesson are that you're going to understand exponential growth, that it's characterized by a rate of growth, something to add to your vocabulary that is proportional to the population size. Definitely add all of this to your vocabulary, flashcards, Google Doc, whatever you've got going on vocabulary. We're going to be able to develop a time series model for the Fibonacci problem, and we're going to test whether the data are exponential. We're going to test whether the data are exponential by comparing the rate of growth to the population size. This is a great time to hit pause, go do question at least 2, maybe 3 and beyond, and then come back and we can work on these together. Question 2, for the moment, assume that the model is an accurate representation of population growth. How many total rabbits, not the pairs, do you think that there will be at the end of 2 years? Go ahead and give an initial gut instinct answer, but then think about the ways to get a reasonable answer that uses some of what you already know about how they grew in the first year. But then question 3 says, hey, let's go ahead and use the spreadsheet. So whatever you want to put as your gut reaction of how many rabbits there would be, I don't know, we were growing pretty fast, so 50,000? Don't know. Just give your own gut instinct reaction, and then we're going to use the spreadsheet. And remember, what we're looking for, it's at the end of 2 years. So looking at the spreadsheet, I've jumped over here to the side, and I've finished off the number of total pairs and then the total rabbits. And then scrolling down, I'm at the end of the 2 years at December, which this would be the total number of rabbits for the end of 2 years. And then if you wanted to go on into the next year, and the curriculum I'm using says that this 150,000 is what we're looking at for the end of 2 years, but actually that's going on into January. So more appropriately, we should say at the end of 2 years, oh my goodness, we'll have 92,736 rabbits. So just below question 3, there are a few more things that I'd like to read. The model being constructed in the spreadsheet is called this, a time series model. Again, add this to your vocabulary. The reason it's called a time series model is that each row in the spreadsheet indicates a single step in time. In our case, it's each month. 1 month, January, the next month, February. And this can be used in a variety of contexts. For example, budgeting is often done as a time series model, where each row represents a month. We're going to use the time series models of population growth. Continuing on, this says that exponential growth is a growth that is proportional to the size of the population. Larger populations are going to grow faster than smaller populations, and as a result, not only will the population grow, the rate of that growth of the population is going to grow. This is often referred to as the snowball effect. When asked if something is experiencing exponential growth, you should check to see if, I'm going to change colors, the rate of growth is proportional to the size of the population. Changing colors again. Hopefully you're writing this down in some notes and some glossary or flashcards. The average rate of change for the rabbit population is equal to the increase in the rabbit population divided by the duration of time that it took to achieve this increase. And so on your paper, depending on which paper you have, you may or may not have this visible, but what that just said is that the average rate of change in population, the average rate of change in population is equal to, right here, is equal to the increase in the rabbit population. So in other words, what's the change in the population? Whatever we're looking at, we're going to look for from here to there. What did we go up? What did we go down? And we are talking about growth, so we're going up. Divided by the change in our time. How much time are we looking at? A year? 3 months? 1 month? What are we going to be calculating this over? We're now going to do some calculations. And question 4, I'm going to go ahead and read through that. Question 4 says, choose 3 periods of growth. They may be different months or longer periods, but the periods should be the same length. So I'm going to go ahead and do this in 3-month intervals. And you can follow me in the same pattern or choose your own. And with the 3-month intervals, on that, I want us to determine the rate of change of the rabbit population for each of these periods, and I'm choosing 3 months. And then we're going to look at something. Are the rates the same? If they are, or if they are not, Then we're going to ask, what does this result indicate? So I'm back at the spreadsheet to answer question 4, and it kept mentioning in number 4, 3 periods of growth. They can be different months that we look at or longer periods, but the periods should be the same. And so what I want to do is, right now I've created a new column called the change in rabbits, and then the change divided by the number of rabbits. And that's not exactly what I want. I want change divided by the time period. So let me go ahead and click on that and ask it to wrap the text for us. So the change in the rabbits, I'm going to go with a 3-month period. In other words, I'm going to tell it equals. I want to take this amount of rabbits and subtract 3 months back and hit equal. So from March or January to March, we grew 2 rabbits. And now I'm going to tell the computer to take that change and divide it by our time period, which was 3 months. I'm going to go 3 more months and do the same thing. And I'm going to be looking at what we're getting over here on the far right to see if there's a pattern, if there's not a pattern, and then we'll be able, as it said at the end of 4, what does this result indicate? So let's repeat this process again. I've got equals, and I want to start with, what is this, June minus where we are in April, hit equal. And then I'm going to do the same thing where I want to tell it to take that change and divide it by those same 3 months. Do we have a matching number? No. They asked us to do this, I think, 3 times. So let's do it one more time. When we do it one more time, we're looking at a 3-month interval. We don't think this one's going to match, but we're just going to do it for the sake of proving our point. So I have a number, a change in the number of rabbits, and that change over the time period. So I'm going to take that number of rabbits and divide it by that 3-month time period. And no, we are not getting the same change. And so since these rates are different, it indicates that the growth in the rabbit population is not linear. If it was linear, then these rates would all be equal and it would represent the slope of the line of the graph of the equation. So we do not have linear growth. So now moving on to question 5, and a reminder, this is always a good time to hit pause, work on it by yourself, and then come back and let's look at it together. But question 5 says, and it did it again. Let me grab that. Question 5 says, can you find any relationship between the rate of the growth of the population and the size of the population? They give us a hint to remind us to go back to the original or the beginning when we're talking like absolute change or relative change, the ending minus the beginning divided by the beginning. And if you investigate like the change from month 9 to month 10, make sure you're going back to month 9 to compare that change. So on our spreadsheet, we were looking at change in rabbits. So let's go ahead and look at that again. Let's go ahead and tell it equals, take February and subtract January, and we get no change. Let's go ahead over here, and it's going to be a little bit different. I'll need to change the title because we're going to go ahead and take this change, but remember we got to go back to the beginning month, and we got to say, oops, hang on. We got to say I want to take this and divide it by my beginning month, and we get 0. And what we were actually doing is we were taking the change in the rabbits, dividing it by a time period of 1, and then we were doing a little bit more. So I'm going to put those in parentheses. But the change divided by the time period, and then we're going to divide all of that by the original population. Whew. So let's do it again. Let's see if we can find a pattern. So remember, we're taking this month and subtracting, which is the ending month, we're subtracting the beginning month. We get 2. And when we go over here to this change, it's that change, which is just for 1 month. So I'm not going to do 2 divided by 1 to indicate the 1 month, and divide it by the original population. Well, no pattern yet. Let's do it again. equals taking the ending month minus the beginning month, and I get 2. I'm going to go do the change, which I want it to say equals. I'm going to take the change in the rabbits and divide it by the original population. It's still not looking good. So let's look for a trend. Let's drag this across the months and then drag this across the month. Oh, looky, looky. Once we get on down to like month 8 in August, it starts to settle in to a change of 62% or 0.62. Keep that in mind, and let's go back to the question that says, go ahead and look for a relationship. And I would say that we're finding a relationship of this 0.62 or 62% as we go through the months, and it's settled into that. So then question 6 says, so if you have a current size of 100, can you use this proportionality that we just found to find a formula for the population size for the following month? In other words, what if the population was 1,000? Use the multiplier. What multiplier should you use to determine the population for the following month in any given month? So using our 0.62 from question 5, if this month we have a population of 100, then instead of going to the spreadsheet, I can just say, well, my next month is going to be 62%, 0.62 of that. And in this case, it would be 100 plus 62 more. That would be 162. And then I would repeat that again. If this month has 162, I'm going to add in 62% of that 162 and get the next month. I'll go ahead and calculate that. So I'm getting 0.62 times 162. And so that is about 162 plus about 100. So we're getting about 262. The same thing would work if we have 1,000. It would be 0.62 of the 1,000. And so we would get, sorry, I'm thumb happy here. We would get our 1,000 plus 620 or 1,620. And we could keep going and going and going. So there's got to be a shortcut. And I remember a lady showed me one time how she calculates tax. I'll do an aside on that, that if I go in to buy an item that's $20 and it's need to pay tax on it, I'm going to need to calculate 0.0825, probably the tax rate where you are if you're in Texas, a tax rate on that, and then I'm going to need to add it back in to the whole amount of 20 bucks. And so she said, instead of calculating and then coming back and adding in what we calculated, treat this as a 1, and then instead of multiplying by the 20 by the 0.0825, multiply it by 1 to represent what we have to add back in, and it's going to be a shortcut to get what we need, and the same thing is going to work for this population growth. Instead of calculating the percentage and then adding it back into the whole, what we can do is we can multiply this 100, not by the 0.62 and then add it back to the 100. Let's just multiply 100 by 1.62, and it should jump us straight to the answer. So I'll grab a calculator, do 100 times 1.62, and my screen has cutting out all this middle stuff, going straight from beginning to the answer. And that leads us on into question 7. Question 7. Did I answer all of that? I think I did. So on question number 7, can you use this proportionality, this, where did it go? Where's my 1.62? I lost my 1.62. So I'll just say, can I use this proportionality to estimate the number of rabbits at the end of 3 years? And remember just a while ago that we came up with the amount of rabbits at the end of 2 years, and we can keep using the proportionality, and let's go ahead and play with it in a spreadsheet. So now to play around a little bit with the multiplier that we were just calculating, I'm going to go back to this spreadsheet where I've already played around with some numbers, and I just want to see if it's going to work. I'm going to see if we use the multiplier on the 754, is it going to truly get us this 1220 that we've already gone through, looked at all of the pairs and everything, and then once we got here, we were doubling the pairs. So what I want to do is I'm going to hit equals, and I want to take the value here, multiply it times our multiplier of 1.62, and then it should be something very similar to the 1220 that it's already in the column. We already know that's about the number that we need, and our multiplier gets something very similar. So just out of curiosity, I'm going to take it on down to here, and by using the multiplier, we're getting, in the previous number, we are getting a very similar number than when we were doing, or as when we were doing the list over here of all the pairs and the young adults and the child. In other words, not the child, the young adults and then the juvenile and then the old adults. We can get a faster result using this multiplier. To answer the question, use proportionality to estimate the number of rabbits. So here we are at February, and let's see if we can get it to do something like, I want it to take the number where we just were and multiply it by 1.62. It'll do it, and now let's see if it'll stretch it on down to the end of the third year. I think I'm there. And oh wow, we get down here and we've got about 30 million. Good grief, that's a whole lot. About 30 million rabbits. That's a lot of rabbits. My brain just can't even wrap around that. But what we're looking at, what we're trying to do here is on question number 7. It is asking us to do an estimation. Can you use the proportionality? And the big picture is, I need you seeing that you can take a population. If you know the multiplier, you can multiply the number that you have times the multiplier, and it will give you or generate the next month. That is a critical idea for what we are doing, and we're stopping at question 7. So this completes lesson 10A. You need to look at your syllabus to see if you have more lessons to do, and if so, let's keep going, and if not, complete all of your homeworks, and we'll see you in another video very soon.